Welcome to my student. Today's lectures we have going to discuss the topic molecular orbital theory. In this topic, now we have going to discuss the points, the molecular energy level diagrams for water molecules, molecular orbital diagrams for water molecules. So in these points, now we have discussed for polyatomic molecules like water molecules. Last time barium dihydride molecules also discussed, but you know that barium dihydride molecules and water molecules, they will have the similar, but the beryllium dihydride molecule is a linear molecules, therefore it shows the geometry is a d infinity H point group. But water molecules are, it is a not linear molecules, but can be shown as the linear molecules. It has C2V type of symmetry, which is shown by those molecules. But those molecules can be formed by the combining atoms as like oxygen and hydrogen atoms. Oxygen it having 8 electrons, hydrogen they will have 1 electrons. These 8 electrons can be distributed as 1s2, 2s2 and 2p4, and the 1 hydrogens having single electrons, but the 2 hydrogens in water, therefore it is electronic configuration is 1s2. Therefore there are in all valence electrons in oxygens which cannot take part in bonding molecular orbitals. Only these 2s2 and 2p4 molecular orbitals and 1s2 molecular orbitals of hydrogen can be combined. That is 6 electrons which is contributed by the central atom of oxygen's atoms and 2 electrons which is contributed by the 2 hydrogen atoms, therefore 2 electron 1s2. So these combines and to get water molecules. But you know that on the basis of linear combination atomic orbital method, the two 1s orbitals of the two peripheral hydrogen atoms can combine and to form the two molecular orbitals. One will have consist of the 1s orbitals with the same sign of the wave functions, that is by addition of atomic orbitals are the psi1, and other wave functions can form by different signs having a subtraction of atomic orbitals psi2 as like, so these pictures. So first wave function psi1 will form by addition of atomic orbitals, like these two peripheral hydrogens like 1s of Ha and 1s of Hb can combine and to get the sigma g molecular orbitals having a similar sign, so psi1. So it can be write as psi1 is equal to the psi1s orbitals of hydrogen plus psi1s orbitals of the other hydrogen. Other molecular orbitals can be formed by subtraction methods. So by subtraction of atomic orbitals like this, the 1s orbitals of one hydrogen subtracted, that is minus other hydrogens, and to get different sign molecular orbitals as a psi2 of wave functions. This wave function of psi2 is equal to psi1s minus psi1s of the other hydrogens. From this linear combination molecular orbitals, the water molecules can appear to be similar to that of barium hydride molecules. That is, in barium hydride, the two hydrogens they will have peripheral hydrogen atoms, and in water molecules it is also the two hydrogens which have a similar to peripheral hydrogen atoms. But the some of the basic difference which is observed lies in fact of barium hydride is a linear molecules in which the 4 valence electrons. But in water molecules, these 8 electrons can be distributed in its molecular orbitals, while water is an angular molecule with the 8 valence electrons to be distributed in these water molecules or molecular orbitals. But it is found in water molecules, they cannot be stable at linear configurations, but it is stable as an angular configuration. From these pictures, we have CR here as like these diagrams are shows that the water molecules, it is a X and Z plane. In this X and Z plane, the hydrogen atom moves towards positive axis. Right here, those hydrogens as moves towards this positive x-axis, positive x-axis, that is the 2px of the oxygen atom, and psi1 orbitals of hydrogen atoms can be overlapped. These psi1 hydrogen atoms can overlap with 2px, these 2px orbitals of the oxygen atoms, and this type of overlap they cause non-bonding pi x 2px linear to become a sigma x, that is sigma x bonding by lowering the energy which is stabilized to the pi y 2py orbitals remains as the non-bonding even in the angular form because of its net zero overlap with this is 1s orbitals of the hydrogen atoms. Now we have also discussed on the basis of SAL the combination of the group orbitals of hydrogens with orbitals of oxygen atom can take place as like these 2s and 2px orbitals of oxygen atoms combine with the group of orbitals of psi1 and to form 3 molecular orbitals, right? 2s and 2px orbitals of the oxygen atoms can combine with the group of orbitals of psi1 and to form 3 molecular orbitals, which is 3. One is a bonding, second is nearly non-bonding or slightly bonding, and other is a anti-bonding as like the sigma s, sigma x and sigma star x molecular orbitals respectively. And other the 2px orbitals of oxygen atoms can combine with the group orbitals of psi2 and to form 2 molecular orbitals, which is 2. One is a bonding like sigma z and one is a anti-bonding sigma star z molecular orbital. So this type of mechanism now we have seen is here as like this. But third one which are very important like the 2py molecular orbitals of the oxygens, which does not take part in bonding because they have the same symmetry as any of the hydrogen atoms. Do not 2py, it is not have the same symmetry and therefore such a hydrogen group orbitals and is non-bonding orbitals. The formation how you delocalize the molecular orbitals like sigma star z. So these pictures we clearly show that these psi2s and psi2px combines, that is 2 molecular orbitals of the oxygens. Which one? Psi2s molecular orbitals of oxygen and psi2px molecular orbitals of oxygens. They can combine with psi1 molecular orbitals or psi1 group orbitals. They form three molecular orbitals. One is a bonding, one is a slightly bonding, and third one is a anti-bonding. As like the sigma s molecular orbitals are formed as a bonding. So it is a psi2s plus psi2px of oxygen plus add group of orbitals like psi1s plus psi1s of the other hydrogens. And second molecular orbitals are formed as like sigma x molecular orbitals, like it is a slightly bonding molecular orbitals. These molecular orbitals can form as like the psi2s molecular orbitals of oxygens plus psi2px molecular orbital of oxygens minus the psi1s molecular orbitals of the one hydrogen and psi1s molecular orbitals of the other hydrogen. Similarly, these antibonding molecular orbitals like the sigma x star can be formed by the psi2s minus psi2px molecular orbitals of the oxygens minus the psi1s molecular orbitals of one hydrogen and psi1s molecular orbitals of the other hydrogen. So these three molecular orbitals are formed by the combination of these two of the oxygens and one is group orbitals of the hydrogens. Other two molecular orbitals are formed from the psi2pz molecular orbitals of oxygens can combine with psi2 molecular orbitals, psi2 group orbitals of this hydrogen. So these two molecular orbitals are formed. One is a bonding and one is an antibonding. So bonding is a sigma z molecular orbitals as like the psi2pz of oxygen combines with these group orbitals of the hydrogens like psi1s minus psi1s other hydrogens. Similarly, antibonding molecular orbitals are formed like a sigma z star is equal to the psi2pz molecular orbitals of the oxygens minus the psi1s molecular orbitals of one hydrogen minus psi1s orbitals of the other hydrogens. So total 5 molecular orbitals can form by combining with these such a molecular orbitals of oxygens with these psi1 and psi2 molecular orbitals. The 8 electrons, which is 8 6 from the oxygen atom and 2 from the hydrogen atoms, can combine and they are distributed in the various molecular orbitals and as in the molecular orbital diagram. The 3 pairs of the electrons occupied by 3 bonding orbitals as like the sigma s, sigma z, sigma x, and a pair of electrons they can remain on non-bonding as like the 2p by pi y molecular orbitals which is localized on the oxygen atom. The electronic configuration of water molecules which is found to be the sigma s2, sigma z2, sigma x2 and pi y2. Therefore, water molecules are the all electrons get paired. So these diagrams now we have see is here. We have clearly shows that the oxygen atoms they will have 1s orbitals is non-bonding, therefore cannot take part. Only 2s and 2p molecular orbitals of the oxygen can combine with the other atomic orbitals of the hydrogen. So firstly, the 2s orbitals of the oxygens they will have 2 electrons. So these 2 electrons can distributed as like 1s electrons are come to here, other of these electrons come to here and to get sigma s molecular orbitals of the water molecules like bonding molecular orbitals. Secondly, the 2p x, 2py and 2pz molecular orbitals they will have each the 1 electrons, and 2 px molecular orbitals having the 2 electrons. So these 4 electrons can be distributed as like the one of these electrons are come to here, one of the electrons is of hydrogens is come to here, and to get the electrons like the sigma s molecular orbitals, right? Similarly, other 2 electrons are come to here like a sigma x molecular orbitals, right? And remaining 2 electrons are come to from this pi y, which are non-bonding electrons which cannot take part in the bonding reaction. Similarly, the sigma z star and sigma x star, which are empty molecular orbitals. Therefore, such atomic orbitals like a group of orbitals of psi1 and psi2 can combine with the atomic orbitals of the oxygens to form the water molecules. Such molecular orbitals as like the sigma s, sigma x, and pi y molecular orbitals. So, in these pictures, we observe that all electrons get paired. Right? No unpaired electrons can remain in this molecule, and therefore the water molecules are the diamagnetic. Right? This photo electron spectrum of water molecules shows the 4 bonds which are expected from its electronic configuration. But water molecule is a diamagnetic due to all electrons in the molecules are paired, right? Therefore, these molecular orbital diagrams for water molecules shows it is a diamagnetic in nature, remaining unpaired electrons. These scientists also the walls shows that the correlation diagrams. It's simply correlation diagrams. After we study, the correlation diagram shows the change in energy of each of molecular orbitals as the bond angle is various in a given molecules are shown as like here. We observe that the central atom, 2s atomic orbitals which are spherical, the bending process causes increase in 1s overlap between the two hydrogen atoms, and hence they may conclude that the movement of nuclei towards the nodal surface and lead to destabilization of the corresponding molecular orbitals, whereas the movement of nuclei leads to stabilization of concerted molecular orbitals. The scientists' rules provide a simple strategy for predicting the various orbitals' energy with bond angle and to predict the molecule with only 4 valence electrons, such as the barium hydride will be linear and water molecules has the 8 valence electrons. They can stabilization of the sigma x will cause molecules to bend structures. Right? So